All right, everybody, moving on from molarity. Okay, molarity, again, is a very specific type of method to measure concentration in a solution because we're dealing with the moles of a substance per liter, and typically that's very specialized. We're going to only use that in the lab. We're going to use that for definitely looking at quantities in a stoichiometric ratio of a balanced reaction. Very, very high precision work when you're in a lab. But in the food industry or in other industries or even general lab work where you're looking for concentration, there are additional ways to do this. And there's many different ways to do this. We're going to highlight a couple different ways or three different ways here that you can also do this. And it's based on something we already did already. So this is really important to be able to do. All right. So basically, the relative amount of solute in the solution can also be calculated using mass or volume. We don't necessarily have to use moles. We can also use the mass or the volume of the solute in the solution. Okay, and this can be used in the medical industry or in the food industry, depending on what your application is. Okay, but one thing you want to remember is that they can be used they're related to the same type of calculation. Okay, which is really the math of the concentration is going to be very, very similar to the part over whole or percent composition. So really that's what we're doing. We're using percent composition or percent concentration to really look at the part, which is usually going to be the solute part, right, over the whole solution. Okay, and that's typically what we're going to do. So it follows the same idea. So all three of these ways to do this, and is not really three different ways, it's based on the same type of way to do it. All right, so the first one is really looking at something by mass. So when we look at the mass of the whole solution, we weigh the whole solution, a certain weight of that is the solute. So if you want to look at that, we would have to find the mass of the solution and then the mass of the solute, do the part over a whole, and look at solute over solution when we weigh it. Okay, and if we do that and we multiply it by 100, we get something called the percent by mass. Okay, and when we use this, we're going to use this for moderate or large amounts of solute, anywhere from a gram or two and higher. Again, you'd have to base this on the application you're using. But if you have a gram per liter or 2 grams per liter or so, you would generally use percent by mass. The problem with this is that if you get down to levels of solute that is so low, then the percentage becomes so low that the number becomes a little cumbersome to use. So, all right, so what we do is when you have extremely small amounts of solute, very small amounts of solute, like hundredths of a gram or thousandths of a gram or millions of a gram per liter, we get down to the point where the mass is so little that the percentage becomes so little. So what we simply do is we adjust this, and instead of looking at part per 100, right, because really a part per 100 is really what a percent is, right? 1 part per 100 would be 1%. We simply change it to looking at parts per million parts, okay? And that allows us to have a number that is more usable, okay? So again, it's based on the same skeleton, though. If you take a look at this part of the calculation and you compare it to that, they are exactly equal. Okay, what's different is the multiplying. Okay, so instead of multiplying by 100 to get percentage, we're going to multiply by 1,000,000, and the unit is not going to be percent anymore. It will be parts per million, or ppm. Okay, we're going to use this for very small amounts of solute. And again, it's not wrong or right to use either one. It's just like how well do you want to present your number? Okay, and typically, so for example, if you're water testing and you're testing the amount of minerals that are in drinking water, you would probably use ppm because you're not going to find several grams per liter of impurities. You'd probably find very small impurities. So that's when you'd use ppm. Okay. So, another way you can link the two is seeing that they are offset by the factor of 10,000, right? So instead of multiplying by 100 here, you multiply by 1,000,000 here. So if you want to go between the two, you can divide or multiply by 10,000. Or you could think of as percentage as percent out of 100 and ppm out of 1,000,000. All right, so it's the same relationship. So in a problem where you want to convert, you'll either be given the percentage and asked to find the ppm, or given the ppm or asked to find a percentage. You can use this clever little adjustment. Okay, and lastly, sometimes what we do is we have liquid solutes. In the case of alcohols or other solvents that you would put, polar solvents you'd use in water. Sometimes what we simply do is we use a volume ratio instead of using a mass ratio. So you take the volume of this volume of the solute over the volume of the solution. Just again, notice the solute over the solution idea. So again, we would use this for liquid solutes. Again, gasoline is a good example of a solvent that has 10% ethanol by volume, because both of those are volume for liquids. So we use that for liquids. Often use this for alcohol solutions. Again, if you bought a rubbing alcohol from CVS in different concentrations, typically it would be a volume to volume solution. Sometimes you even see a weight to volume kind of thing. Okay, and that depends on different types of things. But again, in this class, these are the typical different ways that you can do this. All right, so let's just run a couple of examples of this. Okay, one pro tip, everybody. There's always a pro tip these days in everything we do. Okay, a pro tip, okay, important to know, is that you need to make sure that you have the entire solution in the denominator of this. Okay, I repeat, the solution is the solute plus the solvent. All right, so it's important to know that you need the weight of the whole solution. If you don't have that, you need to get it. Okay, at times, problems will provide only the solvent amount, which is typically H2O. Okay, and if that's the case, you're going to have to make sure you pre-add that water amount to the solute in order to get the whole solution. So what that's going to be is you guys reading really, really carefully when you read these problems. Again, we'll show you some examples here. Okay, so here's some 4 examples. We're going to run through them really quickly together. Have your calculator handy. If you need to pause it and get your calculator, do that. Again, play along with me here. If you just roll over and watch this and do not calculate along with me, it's the work and the practice that gets the best results. All right, so what is the percent by mass of a solute if they're giving you 1 gram of NaCl and they're giving you 49 grams of water? Okay, and they're looking for the percent by mass. What I like to do is box off the question. And again, my percent by mass is going to equal the mass of the solute, okay, again, over the mass of the whole solution. Okay, mass of the solution. Now, this one, remember what I said, they're giving you the mass of the solute, so it's going to be 1.0 grams of your NaCl. However, they're only giving you 49 grams of water. Water is not the solution. Water is the solvent. So we're going to have to add the 1 gram plus the 49.0 grams. So that's going to equal 1.0 grams of your solute over 50 grams, okay, of your water, of your solution, times 100. Okay, and if I do that, I will get 2%. Okay, I will get 2% solution by mass. Okay, so important to know. Well, look what I had to do. I had to do that step. Okay, next one. What is the percent by mass? Again, we're using the same calculation. So we're going to do equals mass of the solute over the mass of solution. Okay, again, you will be given this on the reference table, by the way. It's there. Okay, again, this is times 100, and this is times 100. Okay, all right, so we're given 5 grams of glucose, and you're given 125 grams of solution. Well, this time we do have the solution, so we simply just divide, right? So it's easy. So 5.0 grams over 125 grams times 100, and I get about 4%. A percent by mass of glucose in the entire solution. Okay, pretty easy stuff. All right, so in this case, we're talking about cow's milk containing about 4.5% by mass of glucose. So again, they're giving you the percentage. And now you want to calculate the mass of lactose. That's what we're looking for, right? We'll calculate the mass of lactose in the whole 175 grams of milk. Now, again, you have the percentage and you have the whole. So simply you can just set this up. You can do this 2 ways. You can say, okay, I'm starting with 175 grams of milk, all right, and it says that it's 4.5% lactose. So if you know that's the case, you simply multiply that times 0.045, right? You want to change the percent to decimal. You move that over, 0.45, okay, and you would get about 7.9 grams of lactose. Okay, very similar to what we did in the mole unit when we talked about percent composition. This is very similar. Okay, or what you can do is a clever way to do this. Also say, okay, what does 4.5 mean? It means 4.5% over 100, right? That's what it means, right? It means 4.5 things out of 100 things. Well, what is the mass of glucose out of 175 things? Okay, set up that proportion, and guess what you get? 7.9 grams of lactose if you were to cross multiply. So we're looking good. All right, good shot. All right, so last part, okay, is doing the last problem. And let's just say water was tested at high school East here, and that water report gave us 0.002 grams of lead ions in 1,000 grams of water. Delicious, tastes great. All right, so express this in parts per million. Okay, so we're looking at a very small amount of solute, so it's helpful to do it in parts per million. Okay, it helps. Okay, and they were given grams of water. Now, again, think about this a little bit. Remember, the water tested includes the lead already, so this really is the solution, right? It says water, but it's not pure water. This is water that contains this because it's in the lead. The lead is in this water, so we can assume that it's dissolved in there. So we're going to take 0.02 grams, and we're going to divide that by 1,000. But now what we're going to do is, because we were looking for ppm, we're going to multiply it by 1 million. Okay, and if I do that, I get 2 ppm. All right, so you can see 2 ppm is a lot easier. Now let's just say we wanted to do this for percentage, right? And I wanted to do part over a whole times 100. I would put a 0.002, okay, divided by 1,000, just like I did before, but let me multiply that by 100 instead. And if I do that, okay, I would get 0.002123. No, I would actually have to add another zero. I would get 0.0002%. Okay. Now again, what's easier to kind of manage here? Is it easier to manage and report as 0.0002%, or is it easier to say 2 ppm? And I think you agree 2 ppm is a lot easier to read. It's a lot easier to manage. It's a lot easier to deal with. Okay. And again, since lead in drinking water must be a small concentration to be safe, and again, you usually have a speck of somewhere to be in drinking water, this would be the best way to do it. So again, is it necessarily wrong to represent it as a percentage? No. But it's easier to do it as ppm, and that's why we use it. All right, so I hope this helps. Again, please make sure you guys are going through this, and practicing and making sure you're staying with it through this. Again, solutions can be a little tricky of a unit because we're drawing from a lot of different spots. All right, hope everybody's doing well. Have a great day.